Normal distribution is the most widely used distribution. I'll explain it along with its properties in the next 5 minutes. In January 1901, astronomers discovered Ceres. However, after that, no one had been able to observe the new object. Because of cloudy skies and the object's position in its orbit, it was no longer visible at night, and the sun blocked astronomers' views. At that time, 24-year-old Gauss had been experimenting with mathematical method for which he would later become famous. When he applied this method to Ceres, he came up with different predictions for its position than most other astronomers, and he was right. His calculation enabled astronomers to see Ceres again on December 7, 1801. As you may guess, the powerful tool he used is the normal distribution, also known as the Gaussian distribution, the most common bell curve in statistics. Actually, many real-world phenomena involved random quantities can be approximated surprisingly well by this distribution. In the normal distribution diagram, x-axis represents the random variable's value, and the y-axis represents the probability of that random variable. And the bell curve is symmetrical. Half of the data will fall into the left of the mean, half will fall to the right. The highest point on the curve represents the most probable event. 3 properties of it. First, mean equal to the expected value. As we know, the expected value is often referred to the long-term value. That is the reason why we normally use the average rate of return to evaluate a fund. For the average rate of return can represent this fund's long-term value. However, this only applies to normal distribution. We can't use mean to evaluate other distributions. For example, you won't hear something like a place average earthquake magnitude because it makes no sense. Second, extreme values are rare. 68%, 95%, 99.7% rule. This rule means for a normal distribution, 68%, 95%, and 99.73% of the values lie within 1, 2, and 3 standard deviations of the mean respectively. Extreme values are rare. This sentence has 2 layers of meaning. 1. The probability of an extreme value is very low. 2. The extreme value has a very weak effect on the mean value. Third, the shape of a normal distribution determined by its standard deviation. A low standard deviation indicates that the data points tend to be very close to the mean, whereas a high standard deviation indicates that the data is spread out over a large range of values. By the way, I have written a Python code to generate all the normal distribution diagrams used in here, so if you are interested, please find it in the description. We only need 2 values to draw the normal distribution diagram, mean and the standard deviation. Next, let's see some comparisons between normal distribution. 1. They have the same standard deviation value. In this case, we can compare the long-term value between them. Like products percent of pass, high value means good quality control. 2. They have the same mean value. In this case, we can compare the variability between them. One classic example is comparing 2 funds. As we can see, although they have the same expected value, A is considered good than B. As we can see from the diagram, that the B distribution curve is flatter than A, which results in much more times B's value at the extreme ends of the spectrum. 3. Different mean and standard deviation. In this case, we can find which one is more professional. What I mean, imagine doing a shooting competition. The score I have must have a lower value of mean and a higher value of standard deviation. 3 takeaways. First, in normal distribution, mean equal to the expected value. Second, extreme values are rare. Third, the shape of a normal distribution determined by its standard deviation. I'm always here at your service. See you in the next one.